If you hopped on our fastest spacecraft today, how long would it actually take to travel just one single light year? We hear the phrase light year used constantly in science fiction films, and we see it mentioned often in various astronomy documentaries. In casual conversation, it sounds like a simple unit of time. It feels like something that passes like hours or days. But a light year is not a measurement of time at all. It is actually a mind-boggling measurement of physical distance. It represents the total distance a single photon of light travels. That photon must travel through empty space in one Earth year. Traveling at roughly 186,000 miles per second, light covers nearly 6 trillion miles in 12 months. Six trillion miles is a distance that is incredibly vast. Human brains deeply struggle to comprehend its true physical scale. To put it in perspective, that is over 200 million trips around the entire physical circumference of our planet Earth. If you wanted to walk one light year at a normal pace, it would take you over 225 million years. But what if we use our most advanced space technology? Or what about propulsion systems currently on the drawing board? How do modern rockets hold up against this cosmic ruler? And how do nuclear concepts, or theoretical light sails, compare? It would take you over 225 million years. Today, we calculate the exact travel time for one light year. Let us begin our journey with technology we use every day.
We are talking about standard commercial air travel on Earth.
A standard commercial jetliner cruises comfortably at 500 miles per hour. If a jetliner could fly endlessly through the vacuum of space, completing one light year would take over 1 million years. That is longer than modern humans have existed on Earth. What if we upgrade to our fastest chemical rockets?
These are the ones used for lunar and planetary missions.
Apollo 10 set a speed record returning from the moon.
It traveled at roughly 24,000 miles per hour. At Apollo speeds, crossing one light year takes 27,000 years. Even our most advanced robotic explorers require thousands of lifetimes. Probes like Voyager 1 are currently zooming out of the system. They travel at about 38,000 miles per hour.
Moving at Voyager's current pace, it takes 17,000 years.
This long journey covers only one single light year. Chemical propulsion, which relies on heavy liquid propellant, hits an absolute physical wall when traveling in deep space. To go faster with chemical fuel, you need more fuel. This makes the rocket much heavier and harder to accelerate. Chemical rockets are simply too slow for interstellar travel. They cannot conquer cosmic distances in a human time frame. What is the absolute fastest man-made object ever created? That title belongs to the Advanced Parker Solar Probe. It was specifically designed to study the Sun's outer atmosphere. By diving close to the Sun's massive gravitational well, the solar probe achieves extreme, record-breaking orbital speeds. At its closest approach, it reaches 400,000 miles per hour. That is fast enough to fly from New York to Tokyo in under a single minute of travel time. If a spacecraft could maintain that record speed continuously, how long would it take to travel 1 light year? Even at that speed, covering 6 trillion miles takes 15 centuries. That is roughly 1,500 years of continuous travel time. Furthermore, the probe only achieves that speed using solar gravity. It converts solar gravitational potential energy into massive velocity. Once a probe leaves the Sun's strong gravitational grip, it naturally slows down as it enters deep space. Relying on gravity assists alone cannot solve this speed problem. To reach a light year within 1 lifetime, we need new physics. We must develop entirely new types of propulsion engines. To eliminate heavy fuel, engineers designed alternative concepts. Ion drives use electricity to accelerate individual charged atoms. They shoot these ions out of a nozzle at extreme speeds. While ion engines provide gentle thrust, they run continuously. They slowly build up massive top speeds over several years. An ion craft could reach 200,000 miles per hour. Even at that speed, covering 6 trillion miles takes 15 centuries. To shave centuries off, scientists proposed advanced nuclear propulsion. Projects like Orion proposed detonating tiny, controlled nuclear charges. These small atomic explosions would push the spacecraft forward. A nuclear pulse ship could reach 5% light speed.
That is around 33 million miles per hour.
At 5% light speed, travel time drops to 20 years. Suddenly, a journey of millennia enters a single human career. However, engineering a vessel for nuclear blasts is extremely difficult. Harnessing atomic power remains our best near-future candidate.
What if a spacecraft left its heavy fuel behind entirely?
This is the radical concept behind beamed light propulsion. Instead of carrying heavy fuel, a probe deploys a giant sail. This ultra-thin reflective sail is placed directly in orbit. High-powered laser arrays on Earth fire concentrated beams of light. The momentum carried by light photons pushes the lightweight probe. This accelerates the tiny solar sail to relativistic speeds. Concepts like Starshot aim for 20% of light speed. At this relativistic speed, the physical numbers change dramatically. A microprobe could cross 1 light-year in just 5 years. It would reach Alpha Centauri in roughly 20 years.
At relativistic speeds, scientists must calculate time dilation effects.
For fast travelers, time passes slower than on Earth. Beamed light sails represent our best pathway across interstellar space. Calculating this journey reveals the staggering scale of our universe. 1 light-year remains a grand ruler of human ambition.
Thank you for watching, and keep looking up at the stars.